Starting now to look at specification of programs. And really, we've already seen some of it, okay? And all we're doing is making it more general, something like that, all right? So that's what Wikipedia thinks. In computer science, a program specification is the definition of what a computer program is expected to do. It can be informal, in which case it can be considered as a blueprint or user manual from a developer point of view, or formal, in which case it has a definite meaning defined in mathematical or programmatic terms. All right, so in today's lecture, we're going to primarily look at informal. You can think of informal here as being like documentation. You know, when we write a function, we write some documentation. The documentation is supposed to say something about what the function does, right? You know, and they're good examples. If we go on, let's go here, let's go Java lang object like this, right? You know, there's some pretty good examples. Let's just go pick one that we just happen to know, like the equals method, right? Okay, here you go. So here's an example of some informal, of an informal specification. It's informal because it's written in English. It is a little bit mathematically, you know, so it's a bit more rigorous, I guess, than documentation often is, but it's still in English, and hence it is informal by definition, okay? That's not bad, actually. That's a pretty good, you know, specification, actually, as it goes. When it comes to writing, you know, informal specifications, it doesn't really get much better than that, I'll be honest. Whoa, let's go back to here. So that's an example of an informal one. Whoa. Where are you? There you are. Thank you. And we're going to see some formal ones as well. And we'll see a formal one towards the end of today's lecture. And most of what we're interested in this course, but in this section that we're going to do now, is the formal side. Right? The formal side means we don't write in English. English is a terrible language to communicate in, unbelievably. Because it's like really ambiguous. And you can say things and somebody else can think you meant something different. It's just very unclear what it means. And you already know that, right? Because I say things and you're like, well, what did you mean, Dave? I don't understand what you meant. It's hard. So we want to use something more, you know, precise, right? And we want to use something that we're going to say is formal. In this case, when we're going to use, I guess, something that is programmatic, right? We're going to use a programming language, and we're going to write our specifications in this programming language, okay? So I guess it's not really mathematical, but it is similar to mathematics. If you studied first order logic, for example, in Math 161 or Engineering 123, which should be all of you, right? Hopefully. You remember Math first order logic? You know, quantifiers for all exists, blah, blah, blah. Okay. That stuff is from mathematical logic, but we're going to be using it here in the context of our language. All right, cool. On we go. Okay. So the question is, yeah, well, why? Why do we want to specify programs? Well, I don't know if it's actually exactly rocket science to figure it out, right? We want to say, what is the function supposed to do? That's incredibly helpful. It's helpful to people who are going to use the function. You know, if you want to know what a function does, and you look it up on the Java doc somewhere, then it's good to know, to have some kind of description of what it's actually supposed to do. Otherwise, you have to figure it out, right? And it's quite hard. You know, here's my little function. It's just a max function, and it's just saying returns a maximum of 2 input parameters. Well, that's actually not too bad. Like, it's a useful piece of documentation. It tells me what it's doing. That's okay, right? Specifications are also helpful to you. And when writing your programs, you hopefully will find it helpful to actually write some description of what your functions are doing. I mean, do we do that? Do we like that? Some people are like you, maybe. Well, you'd be amazed to know that when I write functions these days, I almost always actually write some description of what the function's supposed to do. I never used to do that, but over time I do it more and more and more, right? Because it is just incredibly helpful. And otherwise I just get really confused about what my own functions are supposed to do. And it's so easy to get confused about it, in fact. And the final reason, which is something, I guess, of sort of a particular interest for us here, and we can think about it's sort of related to static analysis, is that if we write specifications, and if we write them in a sort of formal language, in a proper, like, programming language, if you like, then we can actually try to check them. We can actually check at compile time, or at runtime, I guess, that our programs meet their specifications. And that's an important thing. You know, and with static analysis, it was trying to do exactly that. It's just the specifications were much more simple. The problem with documentation is that there's no way I can write a tool that will check this. I can't check the documentation. Like, I can't write a tool to do that, okay? I'm just going to basically say, no, I can't do it. All right? I can do lots of things, but that I cannot do. Okay, so here we're just going to see, so we're going to try to start to unravel this issue of how we write specifications in a more formal fashion, right? That's really the key here. And there are two key words. You may have seen them before, possibly in Engineering 123 or similar, which we refer to as the preconditions and the postconditions. And the precondition is the stuff that should be true of the parameters going into the function, and the postcondition is the thing that the function should ensure is true at the end, right? So here we can see I've got my little function. This is still basically computing the max, but over an array of items, okay? And I've got some requires clauses here, right? Those are the precondition of the function. And let's see what it says. So if we look at the first one says requires that items is not null. Okay, so we're not allowed to pass null as a parameter into my max function. That's not allowed. Okay. Also requires that the length of items greater than 0. So that means we can't pass in an empty array, an array of size 0. That's not allowed in the precondition, by the precondition, right? So it's basically saying those are the things that must be true of our parameter items. Okay, and for the ensures clauses, these are the postcondition, right? And we can see if we look, there are a couple here, and they'll make a bit more sense when we get on. But it's ensuring that the item that we return is greater than or equal to all of the items in the items array, right? Because that's what the function is supposed to be doing. It's supposed to be returning the maximum value, right? But actually, that is not itself enough. We also want to say, actually, we need to ensure that actually the item returned is one of the items in the items array. Not just that it's greater than or equal to them all, but it actually equals one of them, right? Otherwise, we could just return some number that was larger than all of the elements in the array. All right? Pretty straightforward. It's kind of the important concept, though, this idea of a precondition and postcondition, and we're just going to basically be working on this. So if there are any questions, don't hesitate. Alrighty. Cool. All right. Have you guys heard precondition before? Is that something you've seen before? Yeah? Okay. All right. Cool. Okay, so here we go. So I just want to start with this. It's just a little exercise to get you going, get you thinking about this, all right? Because I can see it's Monday morning and everyone is already asleep. Maybe because the lights are not high enough. Let's put the lights on. Lights, lights, lights. Yes. So what I want you to do is I want you to take a moment, talk amongst yourselves, and have a think about this program. And I want you to write preconditions and postconditions for this program, this function. Okay? That's the goal. What are the preconditions and what are the postconditions? Okay, all right, let's boogie on. Okay, so we're starting to dig into this thing, and we've already kind of got onto the idea that, well, you know, there are different ways we could write a specification. What is it supposed to mean? Let's put the thing back on so it shows up on the recording. Okay, so in some sense, now we want to think, I want to try and divide this issue of specification up, because the concept of a specification is helpful in terms of thinking about writing programs. In particular, when bugs arise, when problems occur in our program, we want to assign blame. Okay, now, blame is a technical term. It's a technical term, and it means who is responsible for screwing up, right? Which is kind of not that technical, but kind of technical. But we want to know, and it turns out the specifications are really helpful for deciding who is to blame, all right? And we're going to divide it up into two. So we've got, it says a specification is a contract between two parties, the client and the supplier. Or you could think of it as the implementer, that's okay. The client represents the person using the program, and the supplier is the person who implemented it. Now, in fact, right, they could be the same person. You could be the implementer of a function, and you could also be the client using it in another part of your program. That's okay. But in this kind of scenario, we're sort of imagining we've got a client who wants to use the program, and we've got an implementer who is responsible for writing the program. And the specification is this thing in the middle. The specification is the contract that they have kind of agreed to, right? And the contract is basically saying, from the client's perspective, the contract is saying, look, you need to make sure that these inputs are true, or these things about the inputs are true. For example, you don't pass in null, right? And from the implementer's or the supplier's perspective, the contract is saying, look, assuming that the client passed in good input values or correct input values, then you are supposed to make sure that your output matches this postcondition, right? And so the key is we can start to assign blame. So if something goes wrong, we can start to ask some questions. What questions would we ask, or could we ask? If we've got a bug, so let's imagine it. We've got a bug, we've tracked it down, there's a null pointer exception occurring in a function. And we want to assign blame. So how do we use the contract to assign blame? Yes, at the back. Right. So we can ask the question of, was there a precondition that said, for example, this variable is not allowed to be null, but in fact the actual value passed in was null? In that case, the client breached the contract. They are to blame. But on the other hand, if all the input values met the precondition, then that means the implementer is at fault. They are to blame. Right? And that's the deal. And it just turns out to be nice. When we have very concrete specifications written in a programming language, we can actually decide categorically yes or no as to who is to blame. Yes or no, the input values met the precondition. When we write in English, we just end up having an argument about what it really meant. And the client will go, but I thought you meant this. And the implementer goes, well, but no, I thought you meant this. And oh my God, it goes on forever. Right? You know how it is. All right, so here's a little function. This is a function for, what's the right word? Determining the maximum value in an array of values, okay? And so this function meets the specification. That's what I'm saying. The specification, we saw it already. It's pretty straightforward. It's basically saying it returns one of the items in the array, and it returns the largest one. But the precondition is that either the items array itself cannot be null, and the length of the items has got to be greater than 0, right? So if we passed in null, or we passed in an empty array, an array of size 0, then that would be a problem. And we'd see the problem because it would crash, right? If I passed in null, then we'd see a null pointer exception right there. At that point, it's not the implementer's fault. They've done nothing wrong. It's the client's fault. But the thing is, because that null pointer exception happens right there, it's kind of easy to immediately blame the implementation and say, implementation is wrong, it's throwing a null pointer exception. Well, it is throwing a null pointer exception, but it's not wrong. It's doing what it's supposed to do. And that's really the key. And we come down to this other question here, right at the bottom, which we've already touched on a little bit. Is it the only implementation of this function? is this the only way to write a function in Java that will calculate the maximum number in an array of numbers? So the question is, we've written these preconditions, and I haven't put anything in there to check the preconditions are true, right? And so the question is, well, who's responsible for that? Well, in some sense, I'm not really, what's the right word, making any strong suggestions there. It'd certainly be totally sensible and quite appropriate to put in some checks to throw some illegal argument exceptions at that point. The problem you have is that sometimes checking the preconditions is quite hard and computationally expensive, so people don't often want to do it. Using Java assertions is a good option because you can disable them at runtime. In terms of what we're really doing in this course, in this part of the course, it's actually a moot point because we're going to do everything at compile time anyway. Right? So we don't need it, but we'll get to that. Cool. Okay, so the question is, can we implement this in a different way? I hope you know the answer to that question. I'm expecting everyone's hand to go up immediately, without hesitation. How else could I implement it? Just throw some implementations at me. Yes? Streams. Oh, I wasn't thinking of that one. I don't even know how to use streams in Java, right, actually. I looked at Marco's notes, but maybe if you could do a stream over arrays, then yes, you could. That would be totally fine. That's quite an advanced answer. I wasn't thinking about that one, but yeah, that would work. Any other suggestions? Yes, at the back. Yeah, cool. Okay. So interesting to note that this iterates forwards through the array. We could have started at the back and iterated backwards. Totally sensible. Okay. A bunch of other things we could have done. Well, we could have just used a while loop instead, right? We didn't need to use a for loop. That wouldn't make a big difference. And there are some other strange algorithms we could try to apply in this case. So the key is that the implementer has got a lot of flexibility. They don't have to do it in a specific way. The specification is not telling you everything. It's not necessarily indicating exactly how you have to implement the method. Sometimes it does come pretty close, but a lot of the times there is a lot of flexibility in how you implement the method. And different algorithms can be used, and different approaches can be used by the implementer. Right? If it dictated everything, then there'd be almost no point in having the implementer because it would just write itself, right? Cool. All right. So this is it's not super challenging, I don't think. Okay. So the question is, this function, it meets its specification. This is computing the maximum of 2 numbers, and you'll see what I'm doing is I just created a new array. And I put those 2 numbers into it, and I passed them into the max function. So what are the things that we need to think about at this point when we do this? What do we need to think about? We're calling the max function. We saw the max function on the previous slide. It had a whole bunch of preconditions, right? So the question is, does it meet the preconditions? Are we meeting the preconditions here? If we pass in x, y, are we meeting the preconditions? Well, what do we think? Thoughts? Absolutely fine. But when we use the max function, yes, we need to make sure the preconditions are met for that function, right? And the preconditions are, it's got to be a non-null array, and it's got to have at least size 1 or greater. So in this case, it would be fair to say it meets the preconditions, right? So because it meets the preconditions, we can then use the postcondition of that function, which then gives us the postcondition we're looking for in our simpler version of max. All right? So we're just applying the pre- and postconditions for the function that we've called. All right. Yeah. Sometimes, though, like, if you pass parameters into functions, then sometimes you will see their preconditions being sort of become part of your preconditions as well. That does happen, definitely. It's quite normal. It just depends a little bit on what's going on inside, really. Yeah. Cool. All right. Good. How are we doing? All right. Let's boogie on. Okay. Hey, come on. Okay. Cool. All right. So formal specification. So this is really the bit that we care about. And in the next lecture, we're going to spend a lot of time looking at this. Okay, in computer science, Formal specifications are mathematically based techniques whose purpose are to help with the implementation of systems and software. Right? Mathematically based techniques. I guess in our case that will be true, but they're a little bit more like programming based techniques, I guess, you might think. The key is they've got to be written in a well-defined language, and we can precisely determine if the specification is met or not. So we can precisely determine if the input values meet the precondition and if the output values meet the postcondition. English is just no good because it's just ambiguous. We can never be sure if a specification in English is met. All right? It's just impossible. The only way that we can be sure a specification is met is if we get the person who wants it to be built, whatever we're building, to sit down in front of it and say, yes, that's good enough. Right? User acceptance testing, I guess. And so we're going to use this system, and I'm going to talk about it in the next lecture a lot more than I am today. And it's called Whiley. Right? It's a programming language which allows us to write in programmatic terms preconditions in the form of requires clauses and postconditions in the form of ensures clauses. And you'll see that it uses quantification, so this is a for all quantifier, and it also supports existential. This is a there exists quantifier, right? We don't use the mathematical symbols because that's kind of awkward to write on a keyboard, right? And the cool thing about this tool, as we'll see, is that it allows us to check when the specification is met. In particular, given a precondition, does the function ensure the postcondition? And it will do that for us at compile time, most of the time. Sometimes it, within certain limitations, I guess I would say, as we'll see. But the goal is to be sure our functions meet their specifications. That's the idea. Cool. All right. So I'm not going to say too much more about it because we will come back. We're just going to spend a lot of time looking at it. And maybe I'll just fire it up for just a nanosecond. We've got a few minutes left. But before we do, I just want to do one more thing, thinking about specification. In fact, why don't we just bang this straight in? Let's just do that. So here we go. Let's just, hang on, put it straight into Whiley Labs here. All right. Okay, cool. Oh. All right. So this is a little function. It's a contains function. It's basically asking the question, does a particular value x, is it contained in an array x's? Right? So what do we think about this specification? If you see, we've got a postcondition that says if the return r is true, then there is some index in the array where the item, where x equals the element at that position. What do we think about that specification? Thoughts? In fact, not just the specification, what do we think about the implementation in general? Is the implementation okay? Are we happy with the implementation? Has the implementer done a good job? Has he met his part of the contract? So the key is that the specification is somehow weaker than we might like, right? In a sense, the client has made a kind of mistake, I suppose, you could say, in that they've made the specification or the precondition quite weak, and it's basically saying, look, if you return true, then this thing must be true, right? Well, if you don't return true, then it doesn't matter. It's always okay, right? So yeah. So in this case, we might say that we've under-specified our function. Right? That we haven't specified it as much as we would have liked. In contrast, we can also over-specify a function in that we can specify more than we needed to. And that also can be detrimental as well. Cool. All right, so we're pretty much done. So we can run this in Whiley, and it will tell us that, yes, it verifies. But if we pass in this, for example, it will then tell us that no, actually, that's a compile time error. All right? And pretty much, that's the gig. That's the deal. And tomorrow, we're going to look at this in a lot more detail. All right. Till then, have fun.